Hello everyone, this is Anishu, and in this video I'll be using an RF module to make a digital twin of my Arduino based Bluetooth rover and establish communication between the two separate rovers. Now coming to the brief overview of this project, we'll explore how to establish communication between Arduino rovers using an RF433 module. The RF433 is a wireless communication module that operates at a frequency of 433 MHz. The module is easy to use and requires only a few connections to establish a wireless link between the two rovers. We'll start by setting up the RF433 modules on each rovers and then establish communication by sending and receiving data packets between them. We'll also cover some basic concepts of wireless communication and provide a simple code example to get you started with your own project. Also, let's dive in and learn how to establish wireless communication between two Arduino rovers using RF33 modules. Coming to the components that are used to make this project, they are an Arduino Uno, a motor driver, an HC05 Bluetooth module, an RF433 module, breadboard, DC motors, chassis and tires, some jumper wires. For the software, I have used Arduino IDE to write the code and an app to connect the Bluetooth to control the rover. Now, how the flow of data happens with the RF module and two separate Arduinos. As you can see here, first of all, the input is given by the user and using the Bluetooth module, the command is transferred to the Arduino of the master card. The master card interprets the command and acts upon it. Also, the RF433 transmitter attached to it receives the same data and transmits it to the receiver. The receiver then passes on the data to the follower Arduino, and the follower Arduino does act upon it and give output based on the data it receives. Coming to the connections of the master rover, as you can see here in this circuit diagram, the transmitter is connected to the Arduino. The ground pin of the transmitter is connected to the ground pin of the Arduino board. The data pin of the transmitter is connected to the pin number 3 of the Arduino board, and the VCC pin of the transmitter is connected to the ISCP 5V of the Arduino. The rest of the connections are similar to what they have been in the previous videos, so we will not go into that. Now coming to the connections of the follower rover, as you can see in this circuit diagram, the ground pin of the receiver module is connected to the ISCP ground pin of the Arduino board. The VCC pin of the receiver module is connected to 3.3V of the Arduino, while the data pin of the receiver module is connected to pin number 3 of the Arduino board, while the rest of the connections are same as what they have been in the master rover. Coming to the working of the rovers, the RF module in the master card consists of a microcontroller that generates the command and a transmitter that converts the digital signals into modulated RF signals. The RF signals are then transmitted through the air to the RF module in the slave car. The RF module in the slave car consists of a receiver that receives the RF signals and a microcontroller that interprets the signal and executes the corresponding commands. The receiver in the slave car converts the modulated RF signals back into digital signals that can be understood by the microcontroller. To ensure reliable connection, the RF modules operate on specific frequencies in the unlicensed ISM bands and use error detection and correction algorithms, data encryption, and frequency hopping techniques. These techniques help to reduce the effects of interference and ensure that the commands are accurately received and executed. Now I'll be explaining the codes for operating the two rovers. This is the code for the transmitter or the master rover, and it is written in C++ language. The rover is controlled using Bluetooth commands sent from a mobile device, and the commands are transmitted to the RF module digital twin wirelessly. The code uses Arduino IDE and several libraries including wire.h and virtualwire.h. In the setup function, the input and the output pins are defined. The RF transmitter pin is set up and the rover is stopped. In the loop function, the code listens for a Bluetooth command coming from a connected device, and the command is received. It is stored in the input variable. The corresponding RF command is sent to VW sent function of the virtual wire library. After the RF command is sent, the corresponding rover movement function is called to move the rover in the desired direction. The RF commands that are sent wirelessly to the rover are defined as a single character string with F representing forward, G representing backward, L representing left, and stop is represented by S. Overall, this code allows for wireless control of a rover using Bluetooth commands from a remote device and demonstrates the concept of a digital twin that can be used to control physical devices wirelessly. Now coming to the codes for the follower or the receiver rover, this also uses similar set of libraries like the master rover. Also, the RF receiver pin is configured to pin 3 of the Arduino board. The code also defines 5 functions like the master rover, which are also similar: forward, backward, left, right and stop. These functions are mainly used to control the direction of the rover. Now coming to the loop function, in this function the code continuously checks for the incoming messages from the RF module using VW get message function. The first byte of the message is stored in buff array, which is then compared with different characters to determine which function to execute. If the received byte is F, the forward function is called, which sets the motor pins to move forward. If the byte is R, the right function is called, which turns the rover right, and so on. Now with that, the explanation of the code of the master and the follower rover is completed. If the prospect of making a digital twin excites you, then here's a link, follow it to make your own. Finally, it's time for the demo. I hope you enjoy the demo.